Welcome to this film about metals. It's supposed to be really the basics of metals, so it's not only a Year 12 topic at the start of Year 12, but also Year 11. This film will teach you about the structure and the properties that all metals have, and hopefully by the end of it you will understand why it is that all metal atoms choose to form positive ions, and how this fact that they're forming these positive ions actually helps us to understand why a metal structure is the way it is. And then by looking at that structure, we'll see why metals behave the way they do. So why they conduct heat and electricity and how come they're malleable. So first of all, let's look at why it is that metals want to form positive ions. Well, if you remember, we find the metals to the left of this kind of non-existent line, which some people call the stairway to boron. Okay, so here are all the metals over here, and if you've just started looking at this kind of stuff in Year 11, then you remember that if an atom can lose electrons to get a full outer shell rather than gain them, that is to say, if it's got less electrons to lose than it has to gain, so which will be the case for atoms on the left of the periodic table. They'll have less electrons to lose than to gain in order to get a full outer shell. They'll want to lose them. Okay, so they'll form positive ions. Every time an atom loses electrons, it forms a positive ion. So that explains why metal atoms, when they put together, will exist as ions, why it's easy for them to lose electrons. Okay, now if we look at how the particles in a metal are actually bonded together and start thinking about what it's got to do with those electrons, well, here are those positive metal ions. Another word for them is cations. Okay, positive ions are known as cations, and these red dots here in this picture are supposed to represent the electrons that these ions have lost. They're free, or another word for that would be to say delocalized, right? So they're not confined to one atom. Delocalized means they're free to move amongst the ions here. And clearly, if you've got electrons moving around all between these positive charges and the negative electrons attract positive charges, then they're going to act as a kind of glue in between those positive ions. So this is often described as metal ions floating in a sea of delocalized electrons. Okay? And it's the attraction between those electrons and those positive ions that gives the metal structure its strength. Now this slide explains why metals are actually malleable. Now malleable is a term meaning you can change the shape of this thing without breaking it. Okay? So when if you dent your car, it doesn't shatter. Or if you bang into a car, it doesn't shatter, it dents. So that its shape changes, but it hasn't broken. Now this diagram here is supposed to be showing us a metal structure, so those positive ions with the electrons in between, changing shape. So we're moving some of the ions over the others. And just because the ions move, it doesn't mean that the electrons can't attract those ions anymore. Remember, the electrons are free to move around in between these ions. So there's still strength to this structure. In other words, the bonds are still there. The bonds aren't broken by moving the particles in relation to one another. So in other words, you can move the ions without breaking the bonds. And that explains why metals are malleable. Why do they conduct heat and electricity? Well, that's also to do with the fact that electrons can move around. This diagram here is showing all the electrons moving in one direction. They've actually shown a negative charge here and a positive charge as if this was in a circuit. So all the electrons moving towards the positive end of the battery because they're negative and they're attracted to positive charges. So the fact that these electrons can move allows metals to conduct. Try not to get obsessed with the fact that electrons are moving here, because when you describe other structures, it won't be the electrons, but certainly in the case of metals, it is the electrons that are conducting the current. Here's heat flowing from one place to another, and again these particles, because they can move the electrons can move between the particles, they can transfer heat energy from one part of the metal to another, which explains why metals conduct heat very well and why they're good for things like saucepans or cooking foil. And this diagram here, diagram D, actually shows us again the idea of the metal being malleable. That is to say, we can move one set of particles or a row of particles, row of ions, in relation to the next row without actually breaking those bonds and causing the metal to break. Okay, so that's the basics of a metal structure and the properties of metals. Good place for you to go next if you're in year 12 would be to look at the trends that we observe in some of the physical properties of metals as we move around the periodic table.